Hi, welcome to this lesson on number patterns, sigma notations. Let's have a look at what is sigma notation. When we work with long sums, it is easier to write them as one compact term, so some sort of shorthand notation to represent this long sum. This is where sigma notation is helpful. So we use the Greek capital letter sigma, so that's what that symbol means. It's the Greek capital letter for sigma to denote the sum of terms as follows. So this is a helpful way of representing a long sum, whether it be finite or sometimes infinite sum, into some sort of shorthand compact notation that we can read easily. Okay, so this is what we generally used to seeing. So for example, let's say we want to add up the first n terms of some sort of sequence or some sort of general term. So that would be T1, term 1, plus term 2, plus term 3, all the way up to term n. If we want to write this as a shorthand notation, so we want to express this expansion of the sum here, we can use the summation notation, that's what we call it, as follows. So we use the capital Greek letter sigma to represent the sum of terms. At the bottom here, this is called the lower bound, and this means we start adding at this term. So the term I equals 1 here, or the I, the variable, is referred to as the index of the sum. So it's telling you where to start. In this case, for your general term Ti, it's telling you in place of I, start at term 1. Then next, because of the sigma sign you're going to add, then you're going to run through the indices. I equals 1, then I equals 2. Then I equals 3. But how do you know where to end? Well, that is where the upper bound of your summation notation comes in handy. And your upper bound tells you when to stop adding. And you're going to stop adding at, in this case, the nth term. So for example, we're adding from term 1, term 2, term 3, all the way up to term n. So the left-hand side is a nice compact way to represent this very long sum. So let's have a look at a quick example before we end off here. So if I gave you the summation of I equals, for example, let's say 4 up to, let's say, 10 of Ti, what this means is you start where the index is telling you to start. So you're starting at term 4, and then you run up the index plus 1 each time. So it's going to be term 4 plus term 5 plus term 6 and plus term 7. How do I know where to end? I look at the upper bound of the index, and that's going to be plus T8 plus T9 plus T10, and that is where I will stop, because that is telling me where to stop according to the summation notation. Now this Ti is a general term. It could be some sort of sequence that we're familiar working with. It could be an arithmetic sequence. It could be a geometric sequence. So as a further example, if I gave you the sum of I equals 1 to 5 of, let's say, 3n plus 1, that would be some sort of arithmetic sequence. Then or not n, rather, let's put I here, because the index must reference the variable I there. So in the place of I here, you're going to start at 1. So it's going to be 3 times 1 plus 1. That is the first term. Plus, now I'm going to substitute I equals 2. So it's going to be 3 times 2 plus 1. Plus, and then I go I equals 3, so it's going to be 3 times 3 plus 1. And you're going to carry on until you end at the last one, which is I equals 5. So the next one will be I equals 4, it'll be 3 times 4 plus 1. And then lastly, it's going to be 3 times 5 plus 1. And you would just add up, you would do the multiplication, add up, do each term, add it all up together, and that'll give you the total summation from I equals 1 to 5. Now, the variable I is not really special. We could have replaced it. I could have said the sum from n equals 1 to k, if I wanted to, of t sub n. As long as this variable at the bottom here, your subscript for your term, and the index variable line up, that is what is important. Okay, because it's telling you where to run the index over. Okay, so this has been an introduction to sigma notation. We'll do some practice problems and look at some properties of the sigma notation. I'll see you in the next one.